be very good at scale manufacturing. So in order to have the robot not cost like hundreds of thousands of dollars, in order to make it cost like $10,000 or $20,000, fundamentally at scale, the Optimus robot, you should be able to buy an Optimus robot for, I think, probably $20,000 to $30,000 long term.
The miracle is not that a bipedal machine can lift boxes or pour coffee. Boston Dynamics did circus tricks years ago. The miracle is that Tesla aims to do it at a sticker price comparable to a mid-grade sedan. Why does cost matter? Because usefulness is a function of prevalence. An expensive showpiece is a party trick. A $20,000 appliance is an economic force. Will affordable $20,000 robots revolutionize economies or truly become expensive paperweights prized only by elites? Welcome to Tesla Car World. So, how is Tesla Bot Gen 3 a breakthrough in AI? To hit that price point, Tesla leans on the muscle it has already built in Fremont, Shanghai, Berlin, Austin, and now Mexico. The Optimus actuators, control boards, sensors, and, crucially, the 4680 cells ride the same supply chain superhighway that feeds Model Y production. Every penny shaved off a battery tab weld or drive unit casting echoes inside the robot's bill of materials. In pure manufacturing calculus, Optimus is a derivative of Tesla's existing empire, not a standalone moonshot. Inside the husk of Optimus Gen 3 lies a roughly 3 kilowatt-hour 4680 pack. 5 times the volumetric energy density of the old 2170 format allows engineers to bury power in the torso instead of strapping a brick to the robot's back like a jetpack. The result? 22 pounds shed in a single revision, down to 138 pounds all in. Less weight means smaller motors, lower thermal load, cheaper structural members, and efficiency cascade. When Tesla rolled out the first Optimus prototype on AI Day 2022, the robot could barely shuffle across a stage. Fast forward to May 2025 and the third-generation machine tells a radically different story. It now plucks a tennis ball out of midair, executes a synchronized dance routine, and threads a sewing needle, all on video streams released by Tesla in the space of 6 months. At the heart of that leap sits a brand new end effector, a 22 degree of freedom hand that doubles the articulation of Gen 2, 11 DOF, and closes to within 18% of the human hand's 27 mobile axes. Engineer Milan Kovac, who leads the manipulator team, disclosed that each finger is driven by cable and tendon and paired with touch sensors capable of resolving forces under 1 Newton, a configuration that lifts pinch precision from 5 millimeters to 1.4 millimeters, according to Tesla's internal benchmarking. Real-world footage supports the specifications. In the ball catch clip, November 2024, the robot tracks a fluorescent tennis ball traveling at approximately 11 meters per second, about 40 kilometers per hour, and grabs it in 380 milliseconds, with no visible signs of remote control. By May 13, 2025, a second video from Tesla's Austin lab showed 2 Generation 3 units executing a 32-beat shuffle step in sync. Hips, knees, and ankles remaining within plus or minus 1 degree of the intended path throughout the 47-second recording, a tolerance usually associated with motion capture puppets, rather than free balancing bipeds. Independent roboticists have noted that Boston Dynamics Atlas still clears bigger jumps, but Optimus now claims the most articulated production hand in the industry. The jump in coordination is inseparable from an equally aggressive software overhaul. Tesla abandoned classical joint space control in favor of a vision-first stack ported from its full self-driving program. A deep dive explains that Optimus now operates using a streamlined version of the photon-to-control pipeline. 8 global shutter cameras provide input to a transformer-based neural network running on Tesla's full self-driving system on chip, generating 100 Hz volumetric scene graphs. These are then integrated into a model predictive controller that operates at 500 Hz. Latency from image frame to torque command is down to 23 milliseconds, roughly half the figure disclosed for Gen 2 last year. Even more significant is what happens between demos. On May 29, 2025, The Optimus X account posted a clip of the robot folding t-shirts after simply watching 45 minutes of first-person GoPro footage, a switch from teleoperated imitation learning to video-only self-supervision that Tesla says slashes human teaching time by 70%. Beneath the outer shell, Gen 3 is both lighter and more enduring. A teardown shared with interesting engineering estimates the frame weight at 125 pounds, 57 kilograms, driven by 40 electromechanical actuators and powered by a 2.3 kilowatt-hour structural spine battery. This enables the robot to operate through an 8-hour mixed task shift or 4.5 hours of continuous walking at 5 miles per hour. Power consumption at idles around 100 watts and peaks near 500 watts when carrying a 45-pound payload. Figures that place the robot's energy cost of transport below 2 joules per kilogram per meter, already within the broad efficiency range of adult humans. These metrics translate into tangible improvements in capability. Pinch force increases from 8 newtons to 24 newtons, enabling the robot to pick up a raw egg without breaking it, or tighten a 6mm bolt to the specified torque on Tesla's 4680 battery production line. Cycle-to-cycle repeatability in a 3-point pick-and-place task, tested over 1,000 repetitions, shows positional drift limited to 0.6 millimeters, comparable to mid-range SCARA robotic arms that cost as much as the entire robot. The upgraded proprioceptive system, featuring 6-axis inertial measurement units in every limb segment, feeds into a reflex loop fast enough to withstand a 15-kilogram lateral shove. Logs from the Austin demo show center of pressure recovery in 620 milliseconds, with a maximum ankle deflection of 4.3 degrees. By integrating sensing, actuation, and control on a common FSD-grade silicon substrate, Optimus Gen 3 achieves a level of whole-body compliance that begins to look less like scripted robotics and more like biological motor control. Taken together, the 22 degrees of freedom hand, sub-30 millisecond vision loop, and full-shift battery endurance are redefining what a PUBR general purpose truly means in the realm of humanoid robots. Where Gen 1 merely waved, Gen 3 assembles wiring harnesses, stock shelves, and performs solder reflow, tasks that demand human-level finger finesse, not just locomotion. The result is a platform inching toward the threshold at which robots stop being novelties and start filling genuine labor gaps, both on Earth and, if Elon Musk's Mars timetable survives, on other worlds.
This is a super big deal. Like my prediction is that, on this front, is that Optimus will be the biggest product of all time by far. Nothing will even be close. I think it'll be 10 times bigger than the next biggest product ever made.
Mention the term humanoid robot, and many of us, myself included, can't help but envision a sleek, high-tech future where machines effortlessly take over the laborious, risky, or simply tedious tasks we'd rather avoid. Imagine a household assistant that whips up dinner, scrubs the dishes, and handles every mundane responsibility. Tempting, isn't it? Yet, alongside that optimistic vision lies a more anxious narrative. A growing number of people express unease, fearing that such advancements could displace human workers, or even lead to a dystopian scenario where machines dominate us, echoing the plot lines of countless science fiction thrillers. Of course, not everyone sees humanoid robots as the future. For many, they're still little more than awkward, clunky machines, expensive bundles of sensors and wires that can barely stay upright. Some compare their gait to a confused partygoer at 2 a.m., or even poke fun with political jabs. Honestly, the criticism isn't entirely off base. A lot of these robots still struggle to demonstrate real-world usefulness, and it's no surprise that skepticism runs high. But here's the thing, something noticeable has shifted. In just the past couple of years, progress hasn't been incremental, it's been dramatic. We're not just seeing refinements, we're witnessing a leap forward. Not long ago, the spotlight was mostly on Tesla's Optimus and Boston Dynamics' Atlas. Now, it's a full-blown global competition with companies across continents, from the US to China, racing to redefine what humanoid robots can be. To be clear, This isn't about declaring Tesla the undisputed leader in robotic innovation. But if we're talking about meaningful impact, robots that could genuinely transform everyday life, Optimus might just be the one to watch. With a straight face on CNBC last week, Elon Musk repeated a figure that has now become the fulcrum of every discussion about Optimus Gen 3: under $20,000. Musk says that once the Fremont pilot line clears a cadence of 1 million units a year, total bill of materials plus overhead should fall to about $10,000, leaving Tesla free to sell each humanoid for roughly the cost of a used Corolla while still pocketing automotive-class margins. By comparison, a 6-axis Fanuc M20 industrial arm with less than half Optimus's reach retails near $45,000 before end-of-arm tooling, and Hyundai-owned Boston Dynamics still quotes mid-six-figure leases for Atlas. Price alone, therefore, explains why Morgan Stanley's robotics desk values the addressable humanoid market at $5 trillion by 2050, with Tesla the early cost leader. The repercussions of that sticker shock were immediate. When Tesla opened a non-binding reservation portal on May 17th, the form collected 5,000 corporate expressions of interest in the first 72 hours, according to a live walkthrough filmed at Giga, Texas, and later confirmed by staff email to reservation holders. Logistics giant GXO booked 750 units for third-shift palletizing. German grocer Rui asked for 300 to pilot shelf restocking, and Thailand's Bumrungrad Medical Center reserved 120 for nighttime linen runs, 3 sectors with diametrically different wage structures agreeing on one thing. At $20,000, the payback period on a single-shift deployment falls well below 14 months even before tax incentives. Tesla's own internal math is starker. A robot running 2 8-hour shifts in Austin at $18 per labor hour yields an annual EBITDA of $90,000 against $2,000 in electricity, implying the robot repays itself in about 10 weeks and then compounds cash like a rental property with no roof to leak. Crucially, demand is not being throttled by production capacity forever. In January, the company disclosed that its first dedicated humanoid line is already cycling 1,000 units per month, with a second line under construction that scales to 10,000 units monthly by the fourth quarter 2025. 2 months later, an all-hands meeting leaked to Teslarati quoted Musk daring engineers to build a Legion, 5,000 fully assembled bots, before New Year's Eve, and to stock parts for 10 Legions in 2026. Wall Street took the hint. During the first quarter earnings call on April 22nd, Musk told analysts he is comfortable forecasting 1 million units a year by 2029, 4 years ahead of an earlier 2030 target. That trajectory, if met, would make Optimus the fastest ramping hardware product in consumer history, 10 times quicker than the Model 3 and nearly on pace with iPhone's early growth curve. Yet volume alone does not account for the breadth of the order book. Business Insider's roundup of Musk's spring media blitz notes that Tesla has already earmarked thousands of bots for in-house use before outside deliveries begin, effectively turning the gigafactories into 24/7 showrooms where every visitor can watch a robot do value-adding work. Analysts see that dog food strategy as a demand accelerator. Each Optimus that spots welds a battery tray in Austin or shuttles a kitted tote in Berlin serves as a 5'8" salesman wearing no tie. Add the fact that Tesla plans to lease robots at $3,000 down and $2 per operating hour, a figure buried in a Wall Street analyst note that circulated after the Texas demo, and even smaller firms can de-risk adoption by matching payments to direct productivity gains. Behind the scenes, the economics are reinforced by Tesla's well-worn playbook of vertical integration. The same 48-volt powertrain architecture harvested from the refreshed Model 3 slashes inverter costs, while standardized actuators, fabricated on idle gigapress capacity, drive down unit CapEx per joint. Meanwhile, Dojo's wafer-scale accelerators, amortized over the still-growing FSD fleet, handle motion planning inference at 23 milliseconds, end-to-end. meaning Tesla can bundle lifetime cloud compute inside the $20,000 headline price instead of charging a monthly fee. No rival can yet match that subsidy because no rival owns the silicon, the battery cells, and the factory floor. Taken together, the under $20,000 target upends every spreadsheet in industrial automation, and the near instantaneous flood of reservations hints at a backlog that could dwarf early Model S waitlists. Whether Tesla hits the ramp is a separate operational question, but on unit economics and visible demand, the numbers already clear the bar. If Optimus Gen 3 truly lands at car money prices while delivering round-the-clock labor, the robot risks becoming not merely Tesla's next big product, but the standard labor commodity of late 2020 capitalism. The first time in history the price of a humanoid drops below the annual wage of the human it is designed to replace. The Mars window that opens in late 2026 has become the organizing clock for everything SpaceX does, and Optimus Gen 3 has just been written into the countdown. Speaking from the Starbase launch site on May 30, 2025, Elon Musk said, "The first uncrewed starship to the Red Planet will fly in that window, with a simulated crew consisting of one or more Tesla-built humanoid robots, rating the schedule a cautious 50 and 50, but insisting the attempt will go ahead even after the 9th Starship test ended in a loss of vehicle 2 days earlier, which retains 80% of its capacity at -20°C. According to the Universe Space Tech Brief, the Mars variant adds a multi-layer Kevlar polyamide skin for micrometeoroid grit and swaps the glass fiber covers for aerogel-lined carbon panels that keep core electronics above 5°C without the use of heaters. The first tasks are brutally practical: deploy rollout solar wings, trench cable runs, anchor Starlink Phase 2 dishes, and stack regolith Lego bricks into 2-meter berms that have surface radiation and block 90% of dust lift wind. Musk believes a squad of 30 robots working 2 8-hour shifts could raise a 100-kilowatt power station and berm a 1,000 square meter landing pad in approximately 90 Martian solar days, shaving a whole launch window off the timeline for crew arrival. So can a $20,000 robot truly survive Mars better than trained astronauts? Please share your opinion in the comments section below this video.
So in order to have the robot not cost like hundreds of thousands of dollars, in order to make it cost like $10,000 or $20,000.
Most people remain unconvinced by Tesla-bought Optimus robot, despite Elon Musk's bold promise of a $20,000 price tag, and insists manufacturing each unit costs only $10,000. Beyond the headline price in the most recent update video, Tesla-bought Optimus demonstrated an impressive array of household chores, all driven by a single unified neural network. It effortlessly tossed trash into a bin, swept the floor with both a broom and a vacuum, tore off a sheet of paper towel, stirred food in a pot, opened a kitchen cabinet, and drew the curtains closed. The highlight, when Optimus picked up a 4-link component from a Model X and carefully placed it onto a wheeled dolly for transport and even sweep factory floors, tasks that could save or earn users thousands annually. Yet many observers still view Gen 3 as overhyped and question its real-world utility. Humanoid robotics presents far greater AI and engineering challenges than assembling cars, so skeptics wonder whether Tesla can deliver on both performance and affordability. How affordable is Tesla-bought Gen 3 really? Let's talk about value, you see. When most people hear the word price, they immediately brace for impact. But what if I told you that Tesla is flipping that narrative? Elon Musk has shared more than once, 3 times in fact, that the Optimus humanoid robot is expected to come in between $20,000 and $30,000. That's Tesla setting the tone for what affordability could look like in the age of intelligent robotics. And while the latest chatter from Musk on X pegs a future tag of $60,000 for both Optimus and the Cybercab, here's the catch: it's only possible if Tesla scales. Earlier this year, Elon Musk offered a glimpse into Tesla's near future. By the end of 2025, Optimus, the company's humanoid robot, could be ready for customers. Now, let's not pretend it'll hit the market at rock-bottom prices on day one. Like any breakthrough technology, the early stage carries the weight of R&D, fine-tuning, and ramping up production. So yes, the first few Optimus units could land in the $50,000 to $70,000 range. But here's where it gets interesting. That price tag isn't just a number, it's a doorway. In fact, Tesla's long-term projection for Optimus falls between $20,000 and $30,000 once mass production kicks in. That's less than half the cost of a mid-tier EV today. But more importantly, it's a shift in how we think about labor, efficiency, and return on investment. And while early buyers might pay more upfront, they'll likely be the ones reaping the earliest and largest gains. Why? Because Optimus isn't just a helper. It's a force multiplier. Whether it's assembling components on the factory floor, assisting the elderly at home, or performing physically demanding tasks around the clock, this robot doesn't call in sick, take breaks, or need training every few months. What you're really buying is consistency, performance, and the freedom to redirect your human workforce toward higher value tasks. Elon Musk has made it clear. Gen 1 won't be widely available. Tesla plans to deploy about 1,000 Optimus units inside its own factories first. It's a smart move, refining real-world performance before opening the gates. During this internal phase, Tesla gets the chance to optimize both the robot and the workplace environment it serves in. For customers, this means Gen 3, the model aimed at external buyers, will already be road-tested, refined, and ready. Imagine walking into your favorite electronics store and seeing a sign that reads, "Tesla bought Gen 3, only $30,000. After all, today's humanoid robots routinely set you back well over six figures. But that's exactly the rumor Elon Musk let slip during an investor call in June 2025. Gen 3 is poised to crash the market with a price tag roughly equivalent to a used sedan, not a luxury yacht. For those living on fixed pensions, Social Security, or modest retirement savings, $30,000 might still sound steep until you run the numbers on traditional care. Consider a home health aide charging $25 per hour. 2 hours a day, 5 days a week, adds up to over $13,000 a year, and that's before factoring in tip or overtime. In just 3 years, you've watched as much as $40,000 flow out the door, often without any guarantee of consistency if the aide calls in sick or decides to retire. Again. Contrast that with a one-time purchase of Tesla-bought Gen 3, which requires no weekly scheduling, shows up on time every time, and doesn't ask for a vacation. Over the course of 5 years, even if you tack on a bit for maintenance and electricity, you're still looking at a fraction of the cost of human-powered care. But robots break down, you might protest. Fair point, but remember, Tesla already has a worldwide service network for its cars. If your bot needs a tune-up, it'll waltz itself to the nearest service center, or a technician will collect it. And you won't be stuck with a 10-figure repair bill. To put it into perspective, think of trading in your trusty old sedan for a car that can also cook your morning oatmeal. Well, almost. You wouldn't bat an eye if your clunker stopped working 50 feet from the highway on a snowy day. Rather, you'd be furious. Yet somehow, we accept paying double for human aides whose reliability can't be guaranteed. Gen 3's price tag forces us to rethink that logic. And since you're not exactly renewing a mortgage here, Tesla intends to roll out financing plans tailored to retirees, low or zero interest, longer terms, and perhaps even a trade-in credit for older personal mobility devices like scooters or stair lifts. If that sounds too good to be true, consider that Musk has a track record of lowering prices over time. Look at how Tesla cut the Model 3's entry point from $35,000 to under $30,000 within months. So while we're technically talking numbers, what we're really talking about is access. Tesla isn't trying to sell you a robot. They're offering a future where advanced technology fits into real lives, real budgets, and real homes. And that, my friends, is a conversation worth having. Think big. High-profile individuals and corporations where automation isn't just a nice-to-have, it's a necessity. Names like Amazon, FedEx, and Walmart come to mind. These early adopters won't blink at a $50,000 price point because for them, the value is obvious. Operational efficiency, labor cost savings, and let's be honest, prestige. For celebrities, owning Optimus may be as much about convenience as it is about cachet. Imagine a high-profile artist or entrepreneur freeing up time by letting a robot handle errands, scheduling, or simple home tasks. And from Tesla's perspective, every high-visibility placement is free global marketing. You couldn't buy better exposure if you tried. Tesla isn't throwing customers into the deep end. Before Optimus goes on sale, the company plans to roll out a rental program, giving people a chance to see what this technology can really do before making a commitment. We expect the rental cost to fall somewhere between $100 and $500, which is a small price to pay for access to a cutting-edge solution that could soon become indispensable in homes and businesses alike. So, while some might focus on the initial price tag, the real story here is value over time. The early cost is a gateway, not a barrier, and for those who understand how exponential gains work, Optimus could be the best investment they'll make in this decade. How will Tesla's Optimus Gen 3 win over the world's skeptics? It's no secret that many observers still aren't sold on Tesla's humanoid effort, even with Elon Musk insisting a future Optimus will land in the $20,000 to $30,000 range, roughly half the cost of a typical EV. And yet, even after confirming the body's ability to tackle everything from ballet pirouettes to household chores, public enthusiasm remains surprisingly muted. Some critics argue that Optimus Gen 3 doesn't quite match the hype. So, what's behind the hesitation? And how far has Tesla really come? Just as electric cars felt futuristic 10 years ago, Tesla's robots are following a similar arc. Back then, who could have pictured mass EV adoption or governments incentivizing drivers to plug in? Now, Tesla leads the world in EV sales, and its self-driving robotaxi demo recently stole the show, proving their autonomy software is world-class. They could rest on that success, but Musk has bigger plans, turning Tesla into a top-tier tech powerhouse. After revolutionizing transport, his next frontier is life-sized robotics, hence Optimus. Trusting a humanoid with everyday tasks is a big leap. Unlike cars, where you check specs, test drive, read reviews, buying a $20,000 robot requires faith and a promise. To date, Tesla's teaser reels have shown Optimus folding laundry, stacking blocks, sweeping factory floors, and, most recently, tossing trash into a bin, mixing ingredients in a bowl, and even performing a ballet routine. Impressive? Absolutely. But until customers see these moves executed smoothly in real homes and factories, doubts linger. Tesla's journey with Optimus began in 2021, when the project was first launched. By late 2022, Tesla engineers had their first working prototype on display, marking a critical proof of concept. Just 6 months later, in mid-2023, Optimus Gen 1 rolled out, though only for internal use as Tesla fine-tuned its capabilities on the factory floor. Before the year was out, the company introduced Gen 3, boosting its speed by 30% and equipping it with highly dexterous 22-degree of freedom hands. Today, that same Gen 3 model can perform an impressive array of tasks, dancing ballet steps, loading scrap into bins along the assembly line, measuring and stirring ingredients in a kitchen setting, tending to stationary machinery, and sorting battery cells at production line speeds. And the evolution is far from over. Elon Musk recently hinted on X that a completely redesigned Gen 3, informed by thousands of hours of in-house testing, will arrive by the end of this year. When you shop for a Model Y, you'll scour range tests, interior walkthroughs, harsh weather trials, range comparisons, sometimes hundreds of clips and articles. By contrast, Optimus buyers have only a handful of polished demos. Yes, Tesla quietly deploys about 1,000 Gen 1 units across its gigafactories, where robots weld frames, inspect weld seams, clean conveyor belts, and help load finished parts. That field testing sharpens performance, but it hasn't trickled down to public test drives, or in this case, public test works. Creating a humanoid that can learn complex sequences, such as ballet choreography or the nuanced motion of stirring soup, is a monumental AI and engineering challenge. Unlike software updates over Wi-Fi, each Optimus build still requires hands-on assembly and calibration before it can watch and mimic new motions. Tesla's approach, internal stress tests, incremental gen upgrades, is sound, but what customers crave is on-camera evidence of Optimus carrying a laundry basket upstairs, swiftly sorting parts along a moving line, or fetching mail from the door. Boston Dynamics set the bar high, atlas flipping, spot navigating rough terrain. Today, Tesla must outshine mere standing demos. It needs to broadcast Optimus smoothly guiding a pallet into a warehouse forklift, or orchestrating a cooking routine in a real kitchen. How safe is the new design of Tesla's Optimus Gen 3? When you cradle your granddaughter, let's say she tips the scales at about 125 pounds, you feel her warmth, hear her laughter, and instinctively gauge her weight so you don't overstretch your arms. Now, imagine a robot built to that exact weight, but it's engineered to lift your laundry, fetch the morning newspaper, and gently help you rise from your favorite armchair. That's the bold promise behind Tesla Bot Gen 3's revolutionary carbon titanium composite frame. By blending the lightness of high-grade bicycle materials with the unyielding strength of aerospace alloys, Tesla's engineers have delivered a machine that tips the scales at just 125.7 pounds, yet can confidently carry well over 149.9 pounds without breaking a sweat. It directly addresses the daily realities of apartment living and fixed incomes. Traditional humanoid caregivers often weigh north of 176.4 pounds, making them about as welcome in a narrow hallway as a runaway shopping cart in a china shop. You may have seen those viral videos of a factory robot taking a dramatic tumble, sending parts and sparks flying. If that happened next to your heirloom china collection, your heart would skip more than a beat. By contrast, Gen 3's low center of gravity and flexible composite shell allow it to glide past doorways and around furniture without the slightest wobble. Of course, lighter weight also means lower energy consumption, a detail that matters deeply when your monthly budget is set in stone. Tesla estimates that Gen 3 sips about 30% less power than its predecessor, meaning that your electric bill won't balloon into "I can't believe it isn't crypto" territory. For retirees living on pensions or modest savings, that efficiency translates into peace of mind. You can use your dishwasher, microwave, and television without worrying that the bot's own charging cycle will tip you into financial discomfort. In practical terms, the slight hum of its lithium-ion batteries is more soothing than any passbook ever printed. Safety, too, is woven into the very fibers of this robot's design. A 57 kilograms frame equipped with collision detection sensors ensures that if it accidentally bumps into your beloved cat, unlike heavy industrial robots which could send small grandchildren sprawling, Gen 3's composite limbs flex under pressure instead of snapping, so there's no risk of metal shards or sudden malfunctions. It's like comparing President Biden's famously endearing, but occasionally shuffling, walk like Biden, stride to a graceful waltz. Both have character, but only one avoids the occasional stumble and keeps the dance floor intact. Picture this. You're in your cozy living room, the afternoon sun filtering through the curtains, as Gen 3 effortlessly unloads the dishwasher, folds your favorite plaid socks, and deposits them neatly in your dresser drawer. Moments later, it glides into your kitchen to prepare a simple omelet, its arms moving with the precision of a seasoned chef. Throughout the day, it navigates tight corners, low-clearance furniture, and the occasional rogue throw rug with the finesse of a ballroom dancer, all while sipping power so conservatively that your electricity cost barely registers. By harnessing a carbon titanium composite, materials once reserved for jet engines and high-performance cycling frames. Tesla has struck the elusive balance between bulk and brawn. You don't have to rearrange your entire home to accommodate a hulking care machine, yet you gain a helper robust enough to support your mobility needs, from steadying you on the stairs to lifting shopping bags from the car trunk. It's the kind of thoughtful engineering that turns science fiction into everyday reality, without demanding you remortgage your house or sacrifice your beloved armchair. In the grand tapestry of retirement living, where independence and dignity are as precious as health itself, Gen 3's lightweight frame and titanic toughness offer a refreshing promise, a dependable companion that respects your space, your safety, and your budget. No longer must you choose between an oversized mobility aid that dominates your living room and an underpowered gadget that barely clears the floor. With Tesla Bot Gen 3, you finally get a harmonious blend of strength and subtlety. Can polished videos of household chores and factory tasks truly prove Gen 3's worth in everyday life? Please share your opinion in the comments section below this video. Elon Musk may have told you that the Tesla Bot will be able to handle a wide range of household chores, from cleaning to caring for the elderly, and children even serving as a reliable companion. However, what Musk hasn't told you are at least 5 other benefits the Tesla Bot could bring that could make it far more worth buying than simply being a homemaker. Of course, these 5 benefits might spark debate, which is likely why Elon Musk never tell us. But if you've ever thought humanoid robots were just slow, useless machines, you might be wrong. And if you believe they could never be smarter than humans, you'd be wrong again. The insane pace of AI development is taking these machines far beyond what most people imagine, and Elon Musk isn't shy about pouring billions into pushing the Tesla Bot to the limits of usefulness, with plans to start selling it as early as next year. You may feel skeptical, but here are 5 benefits of the Tesla Bot that Elon Musk hasn't told you. Tesla will start selling the Optimus robot in Q2 next year, with the first units going to Tesla employees. This is kind of a tradition for any new product from the company. They make sure it's glitch-free before it reaches outside customers. We mean, if a humanoid robot malfunctions, the consequences could be a lot worse than a faulty EV. Like it could grab a lighter and burn your house down. Okay, just kidding. Since introducing Optimus until now, especially after the Gen 2 version, Elon Musk has repeatedly stressed how useful this humanoid robot will be. And with the kinds of tasks it can handle, demand for Optimus could be limitless. Cleaning, mowing the lawn, cooking, taking care of pets, helping the elderly, teaching kids, and all sorts of household chores. That said, Musk has never mentioned the idea of Tesla Bot earning money for its owners, simply because that would spark controversy about whether it might put human workers out of jobs. While fear-mongering headlines about humanoid robots threatening human jobs are everywhere, we think those worries might be misplaced. In reality, advances in AI and robotics are moving at breakneck speed, opening the door for humanoid robots to take on increasingly sophisticated roles across a wide range of industries. With the stamina to handle repetitive tasks without ever getting tired, the Tesla Bot could be rented out as a robotic worker, taking on factory shifts, handling logistics, cleaning, caregiving, and more, all while generating steady cash flow. If priced under $20,000 and capable of earning around $2,000 a month, a Tesla Bot could essentially pay for itself in less than a year and keep turning a profit long after that. Not stopping there, recently Morgan Stanley's Adam Jonas in a new note. We estimate one humanoid robot at $5 per hour can do the work of 2 humans at $25 per hour, generating a net present value of approximately $200,000 per humanoid. Oh wow. If Tesla pulls this off at scale, we're not just talking about cheap rides. We're talking about the birth of an entirely new economy. Imagine millions of Optimus units doing physical work, logistics, caregiving, even emergency response. You drive down costs, raise productivity, and unlock massive value for society. It's all about AI, energy, robotics converging, and Tesla is one of the only companies building all 3. Yeah. The amount of money Optimus can earn in a year could be unlimited, depending on whether the user knows how to take full advantage of it or not. Some people simply buy Optimus to help with household chores because they don't have time to handle them, while others want to run a business with Optimus. For example, buying them and placing them in their stores so Optimus can operate the business automatically. Let's say you own a food restaurant. One robot takes orders, another cooks, a third serves the food, and another cleans up. Of course, the initial cost of buying 4 robots might make you hesitate, but as we mentioned earlier, you'll quickly recover the investment you put into purchasing Optimus. However, just like every technological revolution before it, the arrival of humanoid robots will not only lead to the replacement of certain jobs, but also create an entirely new ecosystem of work. For example, when ATMs appeared in the 1960s to 1970s, many feared they would take away thousands of bank teller jobs. Yet, over time, the reality was that the number of bank branches actually increased because operating costs went down, which in turn drove the demand for more tellers and financial advisors. Or take the more recent example of Tesla's autonomous robotaxi network. We once worried that taxi and truck drivers would lose their jobs, but it's clear that self-driving cars still require remote supervisors, maintenance technicians, and AI training teams. At the same time, drivers can even register their own vehicles with the network during idle hours to earn income without actually being behind the wheel. So instead of taking jobs away, Tesla will actually be hiring more robot trainers who directly help Optimus expand into new tasks. Next, AI programmers who optimize the performance of each individual robot unit, maintenance technicians who ensure the machines operate reliably, network engineers who oversee the safe operation of the Optimus fleet from the user side, and most importantly, human-machine interface designers, who enable robots to work seamlessly alongside humans in shared workplaces. This marks a significant shift from manual labor to highly skilled, knowledge-based work. Robots will gradually take over heavy, repetitive, and dangerous tasks, freeing humans to focus on creative roles, emotional intelligence, and strategic thinking, things machines cannot replace. That's precisely why Elon Musk chose to deploy Optimus in Tesla's factories first, to prove that robots can create real value while setting a new standard for a blended human-machine workforce. If we understand its true nature, the arrival of the Tesla bot is not simply a threat to jobs, but rather a stepping stone toward a new era of work. In fact, Elon Musk has repeatedly emphasized that the Optimus robot can assist the elderly and teach your kids. However, what he has never publicly mentioned is the potential to deploy Optimus in more professional settings, such as medical facilities, clinics, hospitals, or nursing homes. Clearly, placing a robot like Optimus in these environments could bring significant benefits, if not serve as a fully capable nurse or healthcare worker. Imagine a hospital in California or New York in the near future, where every patient room has an Optimus robot working as an assistant nurse. The Tesla bot wouldn't just bring water or deliver medication on time. It could help patients sit up, measure blood pressure, record vital signs, and even detect early warning signs of health issues thanks to AI systems that process medical data in real time. This is no longer a distant dream, given the rapid advancements in sensors, cameras, image processing, and deep learning algorithms. In a medical environment where precision and consistency are critical to saving lives, a robot like Optimus could even outperform humans in certain routine tasks that are prone to error due to fatigue or workload pressure. We also need to take a clear look at today's demographic reality. According to United Nations statistics, in many developed countries, an aging population combined with declining birth rates is leading to a shortage of workers in essential sectors. By 2050, the proportion of the global population aged 65 and older is projected to rise to 16%, up from 10% in 2022. This means that more than 1 in every 6 people worldwide will be over the age of 65. This translates into increasing pressure on healthcare systems, especially in developed nations like Japan, Germany, and the US. Shortages of nurses, caregivers, and elderly care workers have already emerged and are expected to worsen. In this context, humanoid robots like Optimus are not just a technological option, they are an inevitable solution to a global problem. Moreover, robots don't sleep, don't get tired, and aren't influenced by emotions. During long night shifts, extended surgeries, or emergency situations that demand quick and precise responses, Optimus could become a reliable teammate for doctors and nurses. Instead of completely replacing humans, this robot could serve in a support role, allowing medical staff to focus on higher skill tasks such as diagnosis, decision-making, and providing emotional care to patients. Of course, for the Tesla bot to truly enter the medical field, a range of legal, ethical, and safety challenges must be addressed. A robot operating in a hospital would need certification from health authorities such as the FDA, requiring a rigorous testing and approval process. In addition, patient privacy is an issue that cannot be overlooked. Will patients feel comfortable and trust a robot to care for them? How will sensitive health data be stored and processed? These concerns may be one of the reasons why Elon Musk has not rushed to highlight Optimus's role in the healthcare industry. Another benefit that Elon Musk has never mentioned is Optimus's ability to enhance security for a home, store, or any area that requires monitoring. In fact, the technology inside Optimus is more than capable of allowing it to serve as a bodyguard or security guard. The reason lies in its network of sensors and cameras positioned across its entire body. Optimus doesn't just have a pair of eyes in its head like humans. It's equipped with multiple 2D camera clusters and ultrasonic sensors all over, including on its back. This means that even when standing still, Optimus can observe in every direction at once, a capability that neither humans nor fixed security cameras can match. This 360-degree vision makes Optimus a living security device, constantly scanning its surroundings to detect movement, recognize faces, track suspicious behavior, and respond in real time. Another interesting feature is that the rear camera not only aids in observation, but also supports positioning, allowing Optimus to automatically reverse precisely into the charging station when it needs to recharge. This makes Optimus a fully autonomous unit, requiring no human intervention. It can patrol indoors, outdoors, or around the warehouse throughout the night, then return to charge when the battery is low, like a tireless bodyguard that never sleeps or rests. Beyond its surveillance and patrol capabilities, Optimus can also be integrated with behavior-based threat detection software. If it detects suspicious behavior from strangers, after-hours intrusions, or even violent actions, Optimus can immediately send alerts to the homeowner's phone, automatically trigger alarms, activate strong lights, or record video as evidence. This is especially useful during nighttime situations when security cameras are often limited by lighting or camera angles. Taking it a step further, if connected to a smart home system, Optimus can lock doors, close gates, cut power to hazardous areas, or even guide elderly people and children to safety in emergencies. With internet connectivity, deep learning AI, and object recognition, Optimus is fully capable of enhancing security not only at home, but also at Tesla dealerships, which are sometimes targeted by vandals or people hostile to Elon Musk. When Elon Musk first introduced Optimus, he emphasized that Tesla designed it to replace humans in dangerous, repetitive, or precision-demanding tasks. Although he never mentioned using Optimus for search and rescue missions, it's clear that this robot can be highly useful in some scenarios, which we're about to talk. In recent years, the integration of AI in emergency scenarios has become increasingly common in developed countries. Equipped with the advanced real brain from Tesla's full self-driving system, a flexible physical structure boasting 40 degrees of freedom, and the ability to navigate complex environments, Optimus has the potential to become a breakthrough tool in high-risk emergency situations, such as natural disasters and industrial accidents. For example, during natural disasters like earthquakes or floods, Optimus can be deployed to search for and rescue victims trapped in rubble or flooded areas, similar to the recent situation in Texas. Thanks to advanced computer vision and sensors, the robot can detect signs of life, traverse rough terrain, and even lift heavy objects to clear pathways, reducing risk for human rescue teams. Notably, the Optimus Gen 3 model features impressive water resistance rated at IP69. Optimus's neural network-based learning capability enables it to adapt to unpredictable environments, a challenge that traditional robots often struggle with. In a building collapse scenario, for instance, Optimus can use its flexible arms, each with 22 degrees of freedom, to perform precise tasks such as removing debris or delivering medical supplies to hard-to-reach areas. But that's not all. Although chemical or radioactive leaks are rare, Optimus can take on the critical role of handling hazardous materials or performing decontamination tasks that humans simply cannot approach. Thanks to its ability to operate continuously without rest and its immunity to toxic substances, this robot can enter contaminated areas such as chemical plants with leaks or malfunctioning nuclear reactors to contain and prevent further leaks. Weighing only 140 pounds and capable of carrying loads up to 45 pounds, Optimus can transport necessary equipment without increasing the risk of triggering additional incidents, an enormous advantage over humans in these environments. Moreover, in firefighting scenarios, especially wildfires, the Tesla bot can assist firefighters by accessing hotspots in forest or industrial fires. With the heat-resistant casing of the Gen 3 version, It's more durable even when temperatures reach destructive levels. Optimus can carry fire extinguishers or guide hoses to suppress flames alongside human support. It wouldn't be an exaggeration to say it could even save people trapped in thick smoke. What do you think about training Optimus to serve as a dedicated rescue robot? Drop a comment below. Finally, the possibility of Tesla Optimus being integrated into Tesla's vehicle production line is something Elon Musk has never explicitly mentioned. A concrete example appeared in a test video released a few months ago, where Optimus performed a seemingly simple yet remarkable task. Pick up the Model X4 link from the right cardboard box and place it on the right ramp of the dolly. This was not a pre-programmed demonstration for promotional purposes. In reality, this action requires the robot to recognize objects, distinguish left from right, accurately locate the component in three-dimensional space, and then control its hand to lift and place the part exactly where it needs to go. This is a combination of computer vision, spatial processing, mechanical motion coordination, and adherence to assembly procedures equivalent to the skill set of a trained factory worker on the assembly line. Unlike traditional industrial robots, which are limited to performing fixed tasks in fixed positions, Tesla Optimus is a humanoid robot platform capable of free movement, flexible handling of real-world situations, self-learning from its environment, and adapting to a wide variety of tasks within the factory. It can independently navigate to parts storage, accurately identify the required components, deliver them to the assembly station, and perform necessary operations. This not only saves manpower but also reduces human error, increasing speed and precision in production, especially in repetitive and labor-intensive processes. In the future, with widespread deployment of Optimus, Tesla could completely redesign its production lines in a non-traditional way. No more fixed conveyor belts, no more static assembly stations. Instead, hundreds of Tesla bots would operate flexibly like living mechanics, changing positions and tasks in real time. This vision becomes even more significant when considering Tesla's ambition to produce the affordable Tesla Model 2, an EV priced under $20,000. To achieve this price point while maintaining profitability, Tesla must reduce labor costs, accelerate production speed, and minimize manual errors. Optimus is the key to solving this equation. Instead of building new factories staffed by tens of thousands of workers, Tesla can train a production robot workforce. Optimus units programmed to handle a wide range of tasks and update their skills through software upgrades, something humans simply cannot do. Elon Musk may not have explicitly stated this, perhaps to keep technological secrets or because large-scale deployment is not yet ready, but the reality is clear. Optimus is not just a futuristic helper, it has the potential to become the very heart of labor within Tesla's factories. When that happens, Tesla will no longer be just an electric car manufacturer, it will become a self-operating machine that produces machines. This is Elon Musk's truly revolutionary vision, and Optimus is the final piece in the puzzle to complete the fully automated production ecosystem he has always envisioned. While Elon Musk hasn't specifically highlighted these applications, his vision of Optimus as a multi-purpose robot suggests its potential extends far beyond household chores. If you enjoyed this, check out other videos on our channel that how Optimus robots are mass-produced. It's even crazier than you think. Thanks for watching. Goodbye, and see you later.